Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video, we will learn about the inferential statistics, which is a continuation of our lesson on statistical analysis. So at the end of this lesson, you should be able to understand the concept of inferential statistics and explain the methods to conduct inferential statistics. So first of all, what is inferential statistics? So we had learned that descriptive statistics summarize the characteristics of our data. So next we will need to conduct the inferential statistics that will help us to come to conclusions and make predictions based on the data. So basically, we have the data from a sample, so we can use inferential statistics to understand larger population from which the sample is taken. So why we need to conduct the inferential statistics? So because we want to make estimates about the populations, and we want to test hypotheses to draw conclusions about the populations. So the difference between descriptive statistics and inferential statistics is that descriptive statistics summarize the characteristics of a dataset, while inferential statistics allow you to test a hypothesis or assess whether your data is generalizable to the broader population. So most of the time, we can only acquire data from samples because it is quite difficult or expensive to collect data from the whole population. So perhaps we interested in conducting a study in Selangor perhaps. So it is quite difficult to collect the data from whole population of Selangor. So most of the time we only collect the data from our sample. So while descriptive statistics can only summarize the sample's characteristics, we use the inferential statistics to make reasonable guess about the larger population. So with inferential statistics, it is important to use random and unbiased sampling methods. So if the sample is not representative of our population, then we cannot make valid statistical inferences. So the size of sample size is always smaller than size of the population. Therefore, some of the population is not captured by our sample data, which creates the sampling error. So it is a difference between the true population values called parameters and the measured sample values called statistics. So the sampling error arises anytime we use a sample, even if our sample is random and unbiased. For this reason, there is always some uncertainty in inferential statistics. However, by using the probability sampling methods, it can reduce the uncertainty. So how can we estimate population parameters from sample statistics? So basically, characteristics of samples and populations are described by numbers called statistics and parameters. So statistic is a measure that describes the sample, for example, D as sample mean, and we have the parameter, which is a measure that describes the whole population. For example, the population mean. So sampling error is difference between parameter and corresponding statistics. In most cases, we did not know real population parameter, so we can use inferential statistics to estimate these parameters in a way that takes sampling error into account. So there are two important types of estimates that you can make about the population, which are the point estimates and interval estimates. So point estimate use a single value estimate of a parameter, while interval estimate use a range of values where parameter is expected to lie. So confidence interval is the most common type of the interval estimate. So in confidence interval, we use variability around statistics to come up with an interval estimates for a parameter. So it is useful for estimating parameters because they take sampling error into account. So point estimate give a precise value for parameter, while confidence interval tells uncertainty of point estimates. So they are best used in combination with each other. Each confidence interval is associated with a confidence level which tells probability in percentage of interval containing parameter estimate if we repeat the study again. So for example, 95% confidence interval means that if we repeat the study with a new sample in exactly the same way for 100 times, we can expect the estimate to lie within a specified range of values of 95 times. Although we can say that our estimate will lie within interval a certain percentage of time, we cannot say for sure that actual population parameter will. That is because we cannot know the true value of the population parameter without collecting the data from full population. At the end of the day, we just making estimation based on our sample. If we want to have a true value, we need to have the data from the full population. Okay. So, however, with random sampling and a suitable sample size, we can reasonably expect our confidence interval to contain the parameter a certain percentage of time. So, as I mentioned before, we conduct the inferential statistics to make estimation for the population because we have a sample. So, we want to know the value for the whole population. The second one is because we want to conduct the hypothesis testing. So, basically, hypothesis testing is a formal process of statistical analysis using inferential statistics. So, it aims to compare populations or assess relationships between variables by using samples. So, it can be tested by using statistical tests. Where it also estimates sampling errors so that valid inferences can be made. So, hypothesis testing can be parametric or non-parametric testing. So, parametric tests are considered more statistically powerful because they are more likely to detect an effect if one exists. So, in hypothesis testing, we need to conduct the statistical test which determine where sample data would lie on an expected distribution of sample data if null hypothesis were true. So, this test will give us two main outputs, which are test statistics that tell us how much data differs from null hypothesis of test, and p-value that tell us the likelihood of obtaining results if null hypothesis is actually true in population. So, statistical test is used to determine whether a predictor variable has a statistically significant relationship with an outcome variable, and also it is used to estimate the difference between two or more groups. Statistical tests assume a null hypothesis of no relationship or no difference between groups. Then they determine whether the observed data fall outside of range of values predicted by null hypothesis. So basically, we need to choose the right statistical test depending on our data. Okay, so what does statistical actually do? So basically, it will calculate the test statistics that describe how much relationship between variables in test differs from null hypothesis of no relationship, and then it will calculate the p-value that estimate how likely it is to see difference described by test statistic if null hypothesis of no relationship were true. Then if the value of test statistic is more extreme than the statistic calculated from the null hypothesis, it shows a statistically significant relationship between predictor and outcome variable. If value of the test statistic is less extreme than one calculated from the null hypothesis, it shows no statistically significant relationship between the predictor and outcome variable. So this is what statistical tests do. We calculate the test statistic, calculate the p-value, and based on the value of the test statistic and the p-value, we will examine the relationship between our predictor and outcome variable. Okay, so as I mentioned before, there are two types of hypothesis testing that we can conduct, which is the first one is the parametric testing and the second one is non-parametric testing. So parametric tests make assumptions that include population that sample comes from follows a normal distribution of scores, the sample size is large enough to represent the population, and the variance of each group being compared are similar. So if the data violates any of these assumptions, we need to use non-parametric tests, which will be more suitable for our hypothesis testing instead of the parametric testing. So the non-parametric tests are called distribution-free tests because they don't assume anything about the distribution of population data. So statistical tests can come in three forms, which is test of comparison, correlation, or regression. So basically for parametric testing, we have comparison tests which assess group differences in outcomes, regression tests that assess cause and effect relationship between variables, and we have the correlation test that assess the relationship between variables without assuming the causation. So we will learn about these three, I think, next 2 weeks, I think, during week 7. Okay, next is the non-parametric testing. basically this testing did not make as many assumptions about the data, and it is useful when one or more of the common statistical assumptions are violated. As I mentioned before, there are three assumptions. If any of the three is violated, we need to use the non-parametric testing. However, the inferences they make are not as strong as parametric tests. So these are the types of non-parametric testing. Basically, they are Spearman R, chi-square, Enosim, and what so not. So it actually depending on our on the predictor variable, random, and our outcome variable. Okay, so when we are choosing the our non-parametric testing, like Pearson R, ANOVA, independent t-test, PET t-test, we need to consider, or we need to see our predictor variable and also our outcome variable. Okay. So basically, what test should we use to analyze the relationship or to test our hypothesis? So first of all, we need to see our predictor variable, whether it is a categorical or quantitative. If it is a quantitative variable, we need to see the outcome variable, whether it is a categorical or quantitative. So if it is a categorical, we need to use logistic regression. If it is a quantitative, we need to consider, or we need to see how many predictor variables are there. If it is one, we use simple regression. If it is more than one, we use multiple regression. If our predictor variable is categorical, then we need to see our outcome variable, whether it is a categorical or quantitative. If it is a categorical, we need to choose a non-parametric test. If it is a quantitative, we need to use the comparison of mean test. And then we need to see how many groups are being compared. If it is 2, we need to use t-test. If it is more than 2, we need to see how many outcomes variables are there. If it is 1, we use ANOVA. If it is more than 1, we need to use MANOVA. Alright, so as a summary, inferential statistics help us to come to conclusions and make predictions based on the data. Basically, there are two types of hypothesis testing, which is parametric or non-parametric test, and we need to choose it appropriately based on our data. So I think that's it for this lesson. Thank you so much for listening. I hope you understand. Till our next lesson. Bye bye. Assalamualaikum.